Hi, Professor Husseini. How are you?
Good to see you, and thank you for participating and helping with the session. So let me introduce Lauren, and then we'll get started with the presentation. Lauren Crawford is a professional engineer with over 25 years of experience managing transportation infrastructure in the public and private sectors. She's currently the manager of transportation long-term planning at York Region, with responsibility for transportation planning studies, capital plan prioritization and programming, travel demand forecasting and modeling. Prior to joining the region, Lauren spent over 15 years in the private sector, most recently as a senior transportation consultant leading traveler information systems projects. Very rich transportation background. Thank you, Lauren, again. Please go ahead with the session.
Thank you very much for that introduction. Good morning, everyone. It's a real pleasure to be here today and help moderate this session. This is session 2, data analytics for transportation, and it looks to be quite an exciting one with the lineup of speakers that we have. As many of you, I'm sure, know, data analytics is extremely important, and I'd say actually transformational in transportation. It does provide us with a fact-based approach to gather multiple sources of information to understand, assess, and help develop solutions to complex mobility issues. And these challenges can involve, as you know, movement of people, goods, and services across multimodal networks. And what can also add to that challenge is that those networks are often owned, operated, and maintained across multiple jurisdictions. At York Region, we do use data analytics to help synthesize many data points and present more complete and comprehensive reports on transportation challenges such as traffic congestion, incidents, and travel trends over time. And it's easy to do this now through data analytics and with the help of such visualization tools such as dashboards. So I'll just briefly introduce our first speaker, Yunfei Ma from McMaster University, who'll be speaking to us about freight transportation data visualization. Yunfei Ma graduated from the University of Illinois at Urbana-Champaign with a bachelor's degree major in math and statistics. Yunfei is now a first-year master's student in computational science and engineering at McMaster University. And Yunfei's research focuses on telematics with a focus on origin destination visualization. Yunfei, I'll turn it over to you.
Okay, thank you. And hi, everyone. I'm Yunfei Ma, and I'm a first-year master's student at McMaster University. And today I will be presenting a taxonomy for telematics data visualization for freight transportation based on current research in telematics visualizations. So there are many telematics data and different ways to analyze the data. So how can we provide a structure for a decision maker to better make use of the data through visualization based on level of abstraction and the actual visualization techniques? Then the decision maker can, based on the data visualization, to analyze and decide. So this research is a part of multi-year research project called CLUE. I think many of the students are also involved in this project. So one of the project focus is on telematics. So we are at the phase of exploring and classifying existing techniques in data visualization regarding telematics. So there are 4 metrics that are driving the development in telematics data market. So, and more data are being collected and stored by governments and private companies. So visualization is significant. It can take advantage of human intelligence and computers' computational power. I think a great analogy here is for a modern supply chain is to a self-driving car, which most of the time it's automation, but there are a few interventions if necessary. So in between, visualization is a bridge for decision maker to monitor and possibly optimize for the whole system. A taxonomy based on level of abstraction and visualization technique of current application in telematics data visualization is helpful is a helpful structure for decision maker in free transportation industry. So our approach is based on a bibliometric study and a complete review of over 30 papers from Web of Science that are considered the best practice in the telematics data visualization, and with the help of network analysis tools like GEFI. So there are 3 levels of abstractions: GPS trajectory, origin destination or OD, and speed or travel time. So everything is coming from road telematics, which is similar to the one shown here with location and reporting time. So based on the road telematics data, institution can aggregate the data to trajectory, OD, and speed or travel time for different focuses on objectives or simply for confidential reasons. So for different levels, there are different objectives that can be fulfilled. For GPS trajectory level, there are mainly 5 types of objectives, which are traffic jam analysis, trajectory clustering, monitor of large scale trajectory data, visualization of transportation patterns, model road choices. For example, the objective of multiple road choice could help decision maker to manage risk in free transportation supply chain. And for OD, there are also 5 types of objective: mass rapid transit monitoring and immigration or travel to workflow are mostly focusing on people. Goods flow exploration of urban functions and traffic dynamic exploration are mostly focusing on trucks. For speed or travel time, there are objectives like characterizing movers' travel time, co-occurrence pattern analysis, and bottleneck analysis. So based on the availability of data and types of data, decision maker can match the objectives accordingly. And in the next section, we're going to talk about the actual visualization techniques. So the next part is the visualization technique, which have 3 important components: space, time, and events. One or a combination of these 3 could be applied based on the tasks. So for example, visualization focusing on space mainly represents the spatial information of telematics data. The first graph shows a density map of warehouses in around Atlanta, Georgia. And on the right is a visualization truck trip heads distribution in Atlanta as well. So as we can see, in this region around Highway 20, we can see a light distribution density of warehouses on the left and less truck activities on the right. So this visualization helps to compare the free telematics data with other sources of data for co-occurrence pattern. And these 2 are visualization focusing on time. So this is called a radial map or radial diagram, which is very popular visualization method. So the circle degree represents temporal cycle, like 24 hours a day, and the layers represent 7 days a week, and color can represent attributes like speed or travel time. And the radial map can be used as a fingerprint for a trajectory or spatial clustering as shown here. So the graph here shows each of the radial map acts as a fingerprint to show different traffic patterns for business district, shopping centers, tourist attraction, and industrial parks. Another aspect is event, so which could be based on space or time. On the left is a visualization of spatial event for bottleneck analysis, whereas on the right is a visualization of temporal events of a specific trajectory. A combination of these 2 can help the decision maker to understand both location and periodicity of events like traffic bottlenecks. Also, we can combine components like space and time to better visualize movers' travel using this space-time cube, where space and time are represented in this 3D layout, which is in more detail. So also we can combine all of space-time events together. This is a visualization of stop events at a specific location. Each Rose diagram is a spot for stop events, and the degree of the rose diagram represents different time of the day, and the height of this kind of bar represents how often the stop events happen at a specific time. There are still so many other interesting visualization, possible hybrid visualization, which we do not have time to discuss in detail, but we have already covered the major components of telematics data visualization techniques. So finally, here is an example of a task based on the taxonomy. So let's say we want to do some analysis for free transportation on Highway 4 in Florida. So for data, we have truck telematics speed data. So based on the type and the availability of data, we have a level of abstraction to speed or travel time. So with the objective of bottleneck analysis. So then we can choose visualizing techniques of spatial and temporal events and add the interactive ranking to rank the bottlenecks of the traffic. So the whole system can be helpful for a decision maker to investigate the bottleneck on a specific trajectory. So for conclusion, I'm working on a thorough literature review of current research in telematics visualization, and will add contribution on the visualization technique for freight telematics transportation. So the paper is expected to be done in the beginning of next year. And this research and the taxonomy could be helpful for the application of telematics data from exploring existing visualization techniques and structure it to fit the trend for hybrid visualization, and expand the scope for research with data fusion to follow the trend and development in freight transportation industry. And yeah, that's my presentation. Thank you very much. And if you have any questions, feel free to type them in the chat box. Thank you.
Thanks very much, Yunfei. Very interesting and exciting to see what's coming ahead with your paper.